All right, so today I'm going to be talking about the November 14th guest lecture. So, just a quick showcase. She studied planets and cataloging them and finding where they were in space. So, the main point of the lecture was the lecture discussed how she worked to identify and find planets in far-off stellar systems. She also went into great depth discussing how the telescope that she launched into space with one of the more recent rocket launches works, as well as the process for analyzing the pictures and graphs that come back, as well as the development of the algorithm that finds planets and calculating planets that are found. So here is how she finds planets as they orbit in front of stars. The camera takes pictures, or the telescope takes pictures of far off suns, and it catalogs the brightness of the sun over a great period of time. And then if the brightness dips in a certain pattern, then we can figure that a large body like a planet must have traveled in front of that star. So I found this lecture interesting because it shows how far we've come in studying and cataloging space, and that we still have an incredibly long way to go. So with 5,246 planets are discovered, and so many other planets still left to be discovered and found, it shows how important her project was and how it's still incredibly relevant to the modern study and our understanding of the universe around us. So, what did I learn? One of the most interesting things to me was how extensive the process is for discovering planets, as the planets themselves are way too small to see against the backdrop of space and produce not even nearly enough light to be picked up by a telescope, as the only light they would really produce would be reflected from the sun, which is not close to enough to be trackable. The astronomers must track how the light from the star changes over time and then determine if that's due to a planet passing in front of the star. So these algorithms will track and find patterns that would match that of an orbiting planet affecting the light from a star, and it is an incredibly complicated process. Only certain shapes of the graph would match it due to the fact that there are a great variety of things that could be changing or interfering with the brightness, such as binary star systems with two stars orbiting each other. So, something I already knew. So, something that was discussed, but I already knew about some, at least to some extent, was the specifics of how precise they are with launching this very, very valuable as well as fragile equipment that is the telescope, and how precisely everything is designed as they engineer it to the point that there cannot be any errors. They have calculated for every possible problem they could run into. So a great deal of engineering goes into the telescope. And something, or a particularly specific example that I found was interesting was the sun shields that protects the telescope's like fine electronics and wiring from solar rays and overheating. And as you can see, that's a picture of the one of the panels of the sun shield that will absorb the heat on one side but keep the rest of the telescope cold. So something that sparked my curiosity is that when an algorithm or when the algorithm can't be certain when looking at stars, uh, if the data and graphs would be, or if the data and graphs would essentially state that there's a planet there, if it was not completely sure, then the graphs would be distributed out into the astronomy community as a whole as an attempt to crowdsource individuals who would be able to go over the data again and send their findings back as a way to double check the work and come up with a more sure answer on more dubious cases. So that's a picture of a telescope. So my research after the lecture, one of the topics I was interested in and therefore decided to research was about what percent of stars had planets orbiting them and how prevalent solar system containing as many planets as ours exist. So what I found is that it's widely believed that half of all stars had at least one planet orbiting, with some estimates going up to 70%, and then one in every 6 stars have an Earth-like planet in orbit. And then when I checked how the frequency of systems with many orbiting planets, I was kind of met with a loss, as it seems there hasn't been too much research into the subject, as it's difficult to study planets that have larger orbits like some of the gas giants, and even with some of the ones with close orbits, we've only just begun to research and study them. Thank you.